Hi, in this video, we'll talk about interpreting data. So we know we can visualize data. We can use computation to take a massive data set and create a useful visualization of that data. But how can we best interpret these visualizations to gain new knowledge? How exactly are these visualizations used? So one way these visualizations are used are to allow widespread access to knowledge. So public data sets and data visualization tools to help visualize those public data sets allow widespread access to knowledge. Tools like Google Public Data Explorer and Gapminder allow anyone to dive in and visualize public data and answer questions about it. So if you wanted to compare every country's literacy rate to every country's carbon emissions, you could do that and say, oh, well, maybe there's a connection between knowing how to read and emitting a lot more carbon. Who knows? So that's one way that these visualizations are used. This enables anyone on the internet to find patterns and recognize problems. And this is a good thing. They can be used to educate, but these visualizations can also be used to mislead if you don't know how to interpret them correctly. And we'll be getting into more of this later. So one type of visualization that's available to everyone and can be used to predict things are search trends. So you can look at search trends, you can look at what people are searching on the internet, and this can be used to predict things about the world. For example, here we have the Google search trends for the term fireworks. So we can look at this, and Google makes this available to everyone, and we can say, okay, when are most people searching for fireworks, or when is fireworks have the highest demand? You see that every year in July, the demand for fireworks peaks, the interest in fireworks peaks. And why might this be useful data? Why might this be a useful visualization to someone? Well, imagine you're a fireworks dispenser. Imagine you sell fireworks. You know that every July your demand is going to increase. And because the demand increases, you can increase your price. And this is just one example. You can find search trends for whatever you want. And you can pull really interesting conclusions out of that. It's also very helpful to be able to manipulate these visualizations. So if we can search, sort, and filter through the data that's being visualized, this can help us answer questions. So in this example, maybe we want to look at more than just 2005 to 2015. We want to narrow in on a specific year, or maybe we want to broaden this out and have this not be specific to America. Maybe we want this to be just specific to California, or maybe worldwide. So this is ways we can filter and search through this data and manipulate the visualization. But there are limitations to what exactly we can conclude from examining data and examining these visualizations. A lot of times, what you would want to interpret might not be correct. So visualizations can be very misleading if people skew the axes or the labels, or if they leave out relevant data. And let's look at some examples of this. So here's a very misleading visualization because we call this a truncated y-axis. The y-axis doesn't start from 0. So on the left, you see that the y-axis starts at 3.14% and goes up to 3.15%. And it looks like the interest rates from 2008 to 2012 have exponentially increased. But if you start the y-axis from 0, you see that they've actually stayed about the same. So this can be very misleading. You can lead people to believe that things are blowing up when really they're staying about the same. Here's an example about Bush tax cuts. This graph would lead you to believe that if the tax cuts expire, then the tax rate would quadruple or maybe even quintuple in size. But the y-axis doesn't start from 0. It's actually only going from 35% to 39%. That's not that big of an increase. Same thing here. This poor pitcher, they've made it look like his speed has dropped in half, when really it's only gone down 2 miles an hour. When the y-axis doesn't start from 0, you can make these really misleading visualizations. Another way visualizations can be misleading is if you leave out certain data points. So here we have an example where we have the same data in both graphs. They're both the same data points, but in the graph on the right, we've actually left out every other year. And when you do this, it looks like the trend is going continually up. But if you include every single year, you see that the data is actually a bit more jumpy. It's not a consistent increase. It goes up and down. So omitting data can mislead you and make it look like there's a trend that doesn't exist. Another way that visualizations can be misleading is if the visualization breaks convention. So for example, we're accustomed to having pie charts be a full 100%. But here we have a pie chart that just does not add up to 100%. And when you look at it, it looks like Romney has the biggest slice of the pie, when really, if you look at the numbers, Palin has the biggest slice of the pie. Can you spot the breaking convention here? So in this graph, it looks like the Florida Stand Your Ground law actually decreased gun deaths in Florida. But if you look, the y-axis is upside down. The 0 is at the top. So the stand your ground law actually appears to have increased gun deaths in Florida. But if this image gets shared around on Facebook a million times, a million people might think the opposite. So this is ways that misleading visualizations can dispel incorrect information. And one last way that visualizations can be misleading is picking two random things that aren't necessarily caused by each other, but they might closely correlate. For example, it turns out per capita cheese consumption correlates very closely with the number of people who died by becoming tangled in their bed sheets over time. So we see that in 2000, not that many people ate cheese, not that many people died in their bed sheets. 2006, a lot of people ate cheese and a lot of people died in their bed sheets. It doesn't mean that they cause each other, they're just correlated. So correlation does not imply causality. So it's important to be critical of the visualizations that you see and make sure that they're actually representing true information. So there's a lot of limitations when it comes to these visualizations. One way to be sure that you're actually pulling a valid conclusion from a visualization is to examine the metadata. You need to look at the data about the data that you're looking at. Things like, where was this data collected? Was this only collected in a particular town, in a state, in a country, over the entire world? Who collected this data? Would they have, maybe they're biased. Maybe they want a particular conclusion to be drawn. How long ago was this data collected? Is it fresh? Is it up to date? And how large is this data set that it's coming from? And is this data set accurate? These are all important pieces of metadata that can help us pull a valid conclusion from a visualization. So we need to keep in mind that some questions can't be answered if we don't have the proper data to answer that question. And this just goes back to the scientific method. If you want to test a hypothesis, you need to have the proper data that proves that hypothesis. For example, you can't plot trends over time. You can't plot trends over an entire century if you only have data from 1 year. You can't determine the worldwide opinion on something if you only interview Americans. So you really need to look at this metadata, say, what data do I need to answer this question? And then that's what you need to collect. That's what you need to visualize.